Welcome to second session. Today we will discuss on the second gas law, that is Charles' law. So in this session we'll learn four learning objectives. Charles' law, that expression of relationship between volume and temperature, then how to derive Charles' law equation, and then we'll have some practice on numerical problems. So in short, Charles' law will express the relationship between volume and temperature. We're developing relationship between volume of the gas and its temperature. So in our previous gas law, we learned that volume had inverse relationship with pressure of the gas, whereas in the Charles' law we will have direct relationship between volume of the gas with its temperature. So that means when the volume increases, temperature of the gas also increases, and if the volume of the gas decreases, the temperature of the gas will also decrease, provided that the pressure of the gas remains constant. So now, Charles' law. Charles' law states that at constant temperature, the constant temperature of a given sample of the gas, the volume is directly proportional to the temperature. So that means volume of the gas is directly proportional to temperature when the pressure is kept constant. So that is what Charles' law states. So we now know volume is directly proportional to temperature. Now let us try to derive the formula for Charles' law. As we have already learned that to remove the proportional sign, we have to multiply the right hand side with a constant. So let us do that. Volume, now after removing the proportional sign, it will be replaced with equal value, with the equal sign. So T will be multiplied with the proportional constant K. So we can also write this equation by rearranging it. So we'll take the T to the other side, hence we can write V divided by T is equal to K. So this is our Charles' law formula. V divided by T is equal to constant K. Now let us try to derive the equation for Charles' law. So since we have already derived the formula, that is V divided by T is equal to constant K. So this is our formula for Charles' law. Now to derive the equation for Charles' law, we have to imagine two cases. The initial case and then the final one. Now let us assume that we have a balloon filled with gas. So this gas will occupy the initial volume V1, and also it will have some temperature, that is initial temperature T1. Now in the second case, in our final case, let us take a warm water, and inside this warm water let us place the same balloon on it. So what we will observe is the temperature got increased to T2, that is final temperature, and then the volume of the gas will also increase to V2. also increase to V2. So in initial temperature, we take the volume as V1, temperature as T1. Then for the final, we'll take the volume as V2 and then temperature T2. So this initial and final values, if we expressed with the Charles Law's formula, that is V by T is equal to K. So let us express it for the initial state. So V will become V1, T will become T1 is equal to constant K. Now the same formula, if we express it for the final state, we'll get V2 divided by T2 is equal to again constant K. And we know that both the K constant, they are equal. So now the next step is, let us replace this value, the value of K with this value, and the value of this K with this value. So V1 by T1 is equal to V2 by T2. So this is called Charles' Law's equation. Now let us discuss the activity question. So activity 1.1. For this activity, I want you to turn page number 9, question 1. So let me read the solved problem, question number 1 for you. The temperature inside the refrigerator is about 4 degrees Celsius. About 4 degrees Celsius is the temperature. A balloon is placed inside the refrigerator that initially had the temperature of 22 degrees Celsius and the volume of 0.5 liter. What will be the volume of the balloon when it is cooled by the refrigerator at a constant pressure? So you are asked to calculate the volume of the gas when the temperature is 4 degrees Celsius. So the hint given to us is the value for the initial state, that is T1 22 degrees Celsius, V1 0.5 liter. Then we also provided with the final temperature, that is T2, and we asked to calculate the volume V2, the value that is expressed in degrees Celsius. So let us convert degrees Celsius to Kelvin. So 4 degrees Celsius plus 273 will become 277 Kelvin. And 22 degrees Celsius, if we add 273, we will get 295 Kelvin. So now we are done with the converting degrees Celsius unit to Kelvin. Now let us try to solve the V2. So from the previous lesson, as we have already learned the Charles' Law equation, that is V1 by T1 is equal to V2 by T2. So by using this equation, we will try to solve V2. So before we jump into solving it, we have to arrange the equation in such a way that the V2 is kept in the left hand side and all the other values to the right hand side. So we can also write this equation as V2 by T2 is equal to V1 by T1. So let us take the T2 to the other side. So if you change the T2's position or T2's place from the denominator, it will go to numerator when it changes its sign. So you will get V2 is equal to V1 by T1. So T2 is in the denominator, we will go to numerator T2. Now the final step is substitute all these value with the given values. So V1 is 0.5 liter, T1 is 295, and T2 is 277 Kelvin. So when you calculate it, you get the value 0.469 liter. So you can round it off to 0.47 liter. Okay, now to recapitulate, we have learned about Charles' law, that is the second gas law for our session. And the Charles' law will express the relationship between volume and temperature. So we now know what is Charles' law. We also know the expression of relationship between volume and temperature. We have also derived Charles' law's equation, and also we now know how to use equation to solve problems. So with this, we're done with session 2.